We're going to work with perpendicular bisectors. The perpendicular bisector theorem says if a point lies on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. So we're going to take a look at that and see what that looks like. So we're going to take a look at our first triangle. And let me go ahead and add my arrow onto my line here. All right, so given CD, line CD, is perpendicular to AB. So we have our line drawn, and perpendicular means I have right angles. Given AD is congruent to DB. So we have D here as our midpoint, and so AD is congruent to DB. If it is a perpendicular bisector, bisect means to bisect, to cut in half, cut into two equal parts. So our theorem says that if a point lies on the perpendicular bisector, CD is a perpendicular bisector because we were told that it's perpendicular to AB, and we're also told that AD and DB are equal, so it bisected AB. So then we can say that line segment AC is congruent to line segment CB. The converse of the perpendicular bisector theorem says if a point is equidistant from the endpoints of a segment, then it lies on the perpendicular bisector. Of the line segment. So let's take a look at this one. Given AC is congruent to CB. AC congruent to CB. Given line CD is perpendicular, so creates right angles, to AB. So then we can say AD is congruent to DB because it's perpendicular, and if the two lines are equal distance from that point, it's a bisector. So that would make these congruent. Okay, let's take a look at number one. Number one, we have a perpendicular bisector. We can see that it's perpendicular because it has a right angle. We can see it's a bisector because it divides the third side of the triangle into two equal parts. If we have a perpendicular bisector, then we know that these two sides of the triangle are equal distance from the third side. So to find x, we're going to put 13x minus 48 is equal to 7x plus 24. Notice that I chose to start with my largest term, so I did not have to do symmetrical. 0 pair out the 7x. So I have 6x minus 48 is equal to 24 plus 48 plus 48, 0 pairing it out, of course. 6x is equal to 72. Divide by 6, divide by 6, and x is equal to 12. So if I want to know how long this side is, I'm going to do 7 times 12 plus 24. So I took the side and substituted in our 12. 12 times 7 is going to give us 84 plus 24 is going to make this side 108. So let's check the other side. 13x minus 48. So 13 times 12 minus 48 is 156 minus 48 is 108. So we know that we've done it correctly. They're both the same length. All right, so here we have a triangle, and we're shown that the two sides are congruent. The two sides are congruent. That means that D is equal distance from the two endpoints. If D is the equal distance from the two endpoints, then it must lie on the perpendicular bisector. So that means that we can go ahead and write in our right angles, and we can write in that these two sides are the same length or are congruent. So we're going to go ahead and solve for x. So we're going to do 14x minus 37 is equal to 2x plus 11. Again, I started with the largest variable term. 0 pair out the 2x. So I have 12x minus 37 is equal to 11. 0 pair out the 37. 12x is equal to 48. Divide by 12, divide by 12. X is equal to 4. Now, if I go ahead and add in our label, let's do E, let's do G, and then let's do F. So now we should be able to find EG, because it's going to be 2x plus 11. So 2 times 4 plus 11. 8 plus 11 is 19. And I can find GF, 14x minus 37. 14 times 4 minus 37. 56 minus 37 gives us 19. And that's how you use perpendicular bisectors.